Yes, sir.
Okay. So, Bismillah Rahman Rahim. Let us start once again. Discrete molecules, dot and cross diagrams. We are going to focus on this. Okay. And yesterday we discussed these four molecules. All the dots and crosses we discussed about it. Okay. So now we are going to move forward and see. And drawing such as chloromethane, do not forget to show all the non-bonding electrons on the chlorine atom. So you are going to show all the chlorine atoms non-bonding electrons. What is an octet rule? Octet rule means that every element of the periodic table wants to gain the electronic configuration of the noble gases, especially completing 8 electrons. So that's the octet rule. Okay, complete 8 electrons in its outermost shell. We'll focus on certain molecules like beryllium chloride BCl2, boron trichloride BCl3, phosphorus pentachloride, and sulfur hexafluoride. We'll see these molecules and the structure as well, and we'll see how does it look like. So, for example, if I focus on this molecule BC. Okay, number of electrons around the central atom we are going to see. Beryllium is in group number 2 of the periodic table, so you can see the crosses, they're all for beryllium. Okay, and the dots are all for chlorine. So now you can see how many dots are there very clearly. These dots are all for chlorine. And across, there are 2 crosses which are for boron. Right? This is a linear structure. Linear structure. Okay, linear means that beryllium is exactly in the center, 180 degree of bond angle is there, chlorine on one side and chlorine on the other side. Right? How many bonded pairs do you see? There are. I'm talking about the central atom. The geometry of the molecule is based on the central atom. Keep this in your mind. So, in this molecule, how many bonded pairs do we see? We see that there are 2 bonded pairs. 2 bonded pairs. Okay? Is there any lone pair or unbonded pair? No, there is no lone pair, there is no unbonded pair. Moving on to boron trichloride. So when we focus on boron trichloride, we have boron which is in group number 3 of the periodic table. Okay, under aluminium, above aluminium. And the crosses are all for boron. See, these 3 crosses are there, and the dots are all for chlorine. So the arrangement around boron will be in this way. The bond angle will be 120 degrees. Cl, Cl, and Cl. This structure is called trigonal planar. I call it TP. Okay. Moving on to, and how many bonded pairs are there? 3 bonded pairs are there. There is no lone pair. Moving on to phosphorus pentachloride PCl5. PCl5 is having 1 dot cross, second dot cross, third dot cross, fourth one, and fifth one. Now, how we are going to arrange these 5 pairs around the central atom, and how will it look like? First of all, if I draw boron exactly in the center, I want to please focus there on this one now. These structures are very important now. Phosphorus is exactly in the center. We'll arrange the same way, the way we were arranging. This is a trigonal planar. This is at the top of the trigonal planar, and this is the bottom of the trigonal planar. Yani you have a kind of triangle which is having equal. This is a triangle actually. In this center of the triangle, you will find phosphorus there exactly. Now the bond angle which phosphorus is making here is 120. And you take a piece of paper, cut a triangle out of it which is having equal length of the sides, the edges, and then at the top of that triangle you will find, and you place a pencil at the top of this triangle. This is that. See the structure? So a pyramid is being formed now. One pyramid, you made a pyramid, okay? Place that pyramid on a mirror, and you will see that a mirror image is also going to be formed. And what is that mirror image? See this? This is another pyramid which you will see in that mirror. What is the name of this? This is called trigonal base pyramidal shape. Trigonal base pyramidal. Bond angle, I've told you 120, and the one which is dropping from the top, this bond angle is 90. So you will find a bond angle of 90 and 120. How many faces one pyramid will be having? In this case, there are 3 faces of the top pyramid and 3 faces of the down pyramid. So the structure is hexagonal. How many pairs of electrons are there? 10 pairs of electrons are there, and they are all bonded pairs. Are we clear with this?
Yes, sir.
Okay. These are very important, so you have to draw in this way. This class will be is also recorded, and I'll be uploading it inshallah. Many of the classes I have scheduled for different times. Okay. So the material which I'm getting today will be provided to you within this weekend. You will get all the classes to be uploaded, even this one. Okay. Shall I move on to the second one? Sulfur Hexafluoride Sf6. Now moving on to Sf6. How many bonded pairs do you see here? 1, 2, 3, 4, 5 and 6. There are 6 bonded pairs. How these bonded pairs are arranged? These bonded pairs are arranged like, let me draw it here now. Okay, I need a space, big space for it also. Okay, so how these bonded pairs are arranged now? Sulfur will be in the center. One line, second line, third line, fourth line. Cut a square piece of paper, draw sulfur in the center. Okay, now the bond angle is 90 here. Everywhere it's 90. Now place this piece of paper on the table and take a pen exactly on the top of that paper. This pen will be making 90 angle with it. Take a pen down the paper. The paper is in the middle, one pen is at the top. It's like this. I have it. It's like this, and one is at the bottom, like this. Okay, and these are the corners. So now the bond angle totally is 90. At the top and bottom also it's 90 everywhere. And how will this structure look like? There are two pyramids which are 4-phase pyramid each one. So let me draw the top one. This is the pyramid number 1. Okay, you can see this is pyramid number 1. A square base pyramid. Okay, you take a square base pyramid and place it on the mirror and you get two pyramids. Now let me show you the mirror one. So this is the mirror one which I am drawing. One, second with this one. Okay, 2, 3 and 4 lines are here. So the name of the pyramid is square base bipyramidal structure. So you can write square base bipyramidal structure. Okay, and each pyramid, because it's two pyramids combined together with their bases to each other, is having 4 faces. So 4 is tetra and 8 is octa. We call it octahedral. Octahedral. Right? It's an octahedral or octagonal structure. You can call it an octahedral or octagonal structure. If I zoom out a little bit, and then you see how does these two structures look like, right? Are we clear with this?
Yes.
If you have any question, you can ask right now. There's one more structure which is not given in this book, but they're asking all the time when we are dealing with these structures. It is IF7, here the structure which I'll display right now. IF7. Iodine heptafluoride. Where should I draw it? I will draw it in this area. IF7 iodine heptafluoride. I'm drawing this structure here. Please zoom in a little bit. Or alas. IF7 iodine heptafluoride. That's the name of the structure. So let me write first of all IF7. What's the name? Iodine heptafluoride. Iodine hepta means 7. Fluoride. This is the structure. They are giving this in the exam, but they have not given it here. So let us draw this structure now. First of all, iodine is the central atom. The one which is in this structure, you need to see which element is single. So that will be drawn all the time in the center. So now I'm going to pick up 5 of the iodines and making a base of this. Okay. So when I'm working on 5 of the iodines, 1, 2, 3, 4, and this one is 5. Okay. So this is a star, 5-cornered base. See this 5-cornered base is being formed, right? The bond angle, if you divide 360 by 5, you get 72 degrees. The bond angle is 72 here. One iodine, one fluorine will be at the top and the other at the bottom, right? So This is again a pyramid I'm drawing, but this time this is 5-faced pyramid which you're placing on the mirror. Then you will get this structure. Draw a pyramid which is having a base of 5 corners like this one, 1, 2, 3, 4 and 5. And then this is the top of the pyramid, and everywhere you can see fluorides are there. Fluorine, fluorine, fluorine is connected. Okay, keep that in your mind. These are fluorines. So everywhere you see fluorine, 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 top fluorine and bottom fluorine as well. Okay, there is fluorine here and there is fluorine at the bottom also. There is fluorine also here. Now the structure will be combining this, this and this with it, and you get a 5-cornered double pyramid, 5-face 2 pyramids you'll get. So it's actually pentagonal base bipyramidal structure. So let me zoom out a little bit. Pentagonal base bipyramidal structure. So this will be called pentagonal base bipyramidal structure. So let me write with, it will be called pentagonal base pentagonal or pentagonal base bipyramid or pyramidal structure. Right? Are we clear with these structures?
Yes, sir.
Okay. Moving a little bit towards the top. What is the name of this structure? CH4. Let me name this structure. The name of this structure, CH4 is a ring. C is in the center, 1, 2, 3 and 4. The bond angle is, what is the bond angle? 109 point. 109.5 degrees. That's the bond angle. And the name of the structure is tetrahedral. When you see that there is a central carbon and there are 4 lone pairs around it, it will be tetrahedral. Okay? Then coming towards ammonia, the structure is ammonia, nitrogen is in the center. Hydrogen, hydrogen and hydrogen. The structure name is pyramidal. And when we talk about water, oxygen in the center. Okay, 2 lone pairs are there. In ammonia, 1 lone pair is there. In water, there are 2 lone pairs. The structure is V-shaped. You can call it angular as well. The bond angle is 104.5. And in ammonia, the bond angle is 107 degrees. Okay? When you talk about pyramidal, it's always 107. When you talk about tetrahedral, it's always 109.5. When you talk about V-shape, it's always 104.5. Right? One more structure which I want to draw for you is carbon dioxide. Carbon dioxide, let me change the color. Carbon dioxide, carbon is in the center. There is a double bond with oxygen, another double bond with oxygen. So 180 bond angle is there. It's a linear structure. Okay? Are we clear till this point?
Yes.
Okay. How we are going to decide which structure is correct? The one which we have drawn, their correct structure or not, there is a concept behind it. We'll discuss this concept inshallah in some other class. Okay? And we will see that whether we are drawing the structures, are they the correct structures or we're just drawing it. Right? So inshallah we'll discuss this in the next class. Now at the moment, if you have any question, you can ask me. Do you have any question? And then I'm drawing that structure. CH4 is the ideal structure for me, okay, which is methane. Okay, so C1, 2, 3 and 4. How many bonded pairs are there in it? Dot and a cross, dot and a cross, dot and a cross, dot and a cross. So there are bonded pairs and lone pairs, okay? Bonded pairs are 4 in it. There is no lone pair. Okay, so 0 lone pair is there. This is my ideal structure. Bond angle is 109.5 degrees. 109.5 degrees. Okay, and it is named as tetrahedral. Okay, that's the structure. Now, if I bring changes to this structure, I can go for some other structures. For example, one lone pair will cause me a fall of degrees of 2.5. Okay. So if I draw these two electrons, it's a lone pair. Dot and cross and dot is bonded pair, and cross is also a lone pair, right? So every lone pair, if you introduce, it will fall the degree by 2.5 bond angle. For example, CH4, 4 bonded pairs are there. Bond angle is 109.5. If I change this one into a lone pair, so the new structure with me will be like this, and I'll draw this lone pair on it, right? Are you with me?
Yes, sir.
Okay, at this time it will be -1 charge holder, okay? And this lone pair will fall the bond angle -2.5. So how much will be the bond angle? It will be 107 degrees. For 107 degrees of bond angle, what is the shape of the molecule? We call it pyramidal. Right? Are we clear?
Yes, sir.
Okay. I need to share with you the Microsoft whiteboard, and I will draw there on it so that we can Please turn on your cameras. Those who just got online, please turn on your cameras. Now I'm introducing more and more bond pairs to the same structure. I told you my ideal structure is methane. So CH4, now I want that CH4 should give me a structure with 2 lone pairs on it. -2 charge will be there, most probably. When there are 2 lone pairs, CH4 was having how much bond angle? 109.5. And when 2 lone pairs are there, 2 times 2.5, which is 5 now. So you will subtract this and you will get the bond angle to be 104.5. So it's just like water. It's just like water structure where there are 2 lone pairs and the bond angle is 104.5. So it is angular or V-shaped. Okay. Are you clear with this?
Yes, sir.
Okay. Now, if the CH4 is not having any lone pair and there are only 3 bonded pairs, yani C with an H, positive charge on it, the electron is lost, there's a plus charge on it. So the bond angle between these two will be 120 degrees, okay, and it will be trigonal planar. Right? Are we clear with this?
Yes.
Okay. I'm moving to the structures H2S. Sulfur belongs to a group of oxygen. So it's just like I'm drawing the part A structure. So moving on to that structure, H2S I will draw here. Keep telling me the structures from the book if you have the book open with you. I'm drawing H2S, sulfur in the middle, then H and then H. It's like oxygen because it's in the oxygen family. So 104.5 degrees. It's angular or V-shaped. Then we have BH3. Boron is in the nitrogen family. There's a lone pair, right? So it is. It's boron, or which one is that? PH3. Sorry, not boron. PH3. So it's P, phosphorus in the nitrogen family. Boron is in the aluminium family. Phosphorus. So it's pyramidal. Okay. Moving on to the structure PF3. Again, phosphorus is there. P in the middle. One fluoride, second fluoride, fluoride. It's again pyramidal. Bond angle is 107 degrees. Okay. And the next one is SCl2. S is in the sulfur family, sulfur just like oxygen. So SCl2, this is S, this is Cl, and this is Cl. This is angular or V-shape. You have to draw the rest of the dots and the crosses also. You can draw the crosses, cross, full-fledged structure you can draw. Okay. You can draw these structures like this. So it's angular, or you can call it V-shaped. Your examiner will accept both of these. There is no restriction on it. So, moving on to AsF5, arsenic belongs to which family? Tell me about it. Where is arsenic in the periodic table? It's under phosphorus, right? It's under phosphorus. So the structure will be exactly AsF5, right? AsF5. So the structure will be the same, trigonal planar sort of a structure. Trigonal base, bipyramidal shape. This is the pyramid which is being made. Okay, and it's a trigonal base bipyramidal. So F, alright, are there. It's called trigonal base, and in the base is triangular bipyramidal. Okay, SF6. Moving on to HCN. And then SO2. Moving on to HCN. I'll draw the structure of HCN for you. HCN. So this is H single bond and then C triple bond N. Structure is almost 180 degrees. It's linear. Okay. And then we have the final structure, which is sulfur dioxide. S double bond O, double bond O. Okay, so this structure is also angular, or you can call it E-shaped. Both are accepted by your examiner. Okay. Are we clear till this part?
Yes.
Any question you can ask. If you have any question, you can ask. We will work on the Lewis dot cross diagrams, whether the diagrams or the structures that we are drawing are correct or incorrect, but we will be doing this in the next class, inshallah. Okay. Dative covalent bond, we have already discussion about the dative covalent bond, a bond which is made between.
Yes.
A dative covalent bond is formed when one of the element is providing an empty orbital and the other one is providing a pair of electron to it. So it's a 100-0 sharing. Okay, and that 100-0 sharing is resulting in dative covalent bond. Okay. Now, in case of ammonia, if you look into that one, in case of hydroxonium ion, look at this. If I zoom in a little bit here, see, this is a dative covalent bond actually, and we are showing this dative covalent bond with an arrow. Okay. The plus charge is because one extra proton has been added. So actually how it was happening, oxygen is here with 2 hydrogens on it, okay, and 2 pairs of electrons. So it's offering this to this hydrogen positive, and then this structure is formed. Okay, this is how the dative covalent bond is arising. The same dative covalent bond can be seen in case of ammonium ion formation. You can see this is dative covalency. Okay, in the same way, nitrogen was offering a pair of electron. You can draw in this way for your convenience. It's offering a proton to H positive, a pair of electron to a proton, and then you get this sort of a structure. This structure is actually tetrahedral. Okay, this is tetrahedral now, and this is the dative covalent bond. Now, when you're drawing tetrahedral perfectly, and then this will be tetrahedral. Once the dative covalent bond is formed, nobody can differentiate which one was the dative covalent bond. Which one? This one, or this one, or this one? Because you cannot differentiate between electrons. Okay. Keep in mind, the hydrogen positive ion, when it's coming, it's just providing the orbital, only providing the orbital, and the pair of electron is provided by nitrogen. So there is no difference made to nitrogen because the pair still is there. The number of electrons, if you count 2, 4, 6 and 8, it should not exceed an 8. That's the Octet Rule, that the number of electrons should not exceed an 8. And it can only accommodate 8 electrons there. And hydrogen can accommodate 2 electrons. That's why it's just only providing its shell or its orbital. We talked about Al2 Cl6 structure as well. This is AlCl3, the normal structure, which I told you previously also, that how this structure is being formed. So now you can see 1, 2 and 3, these are covalent bonds. So 2 times 3 will give you 6 electrons. The octet still needs to be completed. So if there is a dative covalency, then the dative covalency can fulfill that octet rule. And then we worked on the dimer, and the dimer is, I think, given here. Yes, see, this is the dimer now, and already explained in my previous lecture to you the dimer. Okay, so you can see this is normal covalent bond, dot and across, dot and across, dot and across. Then the 2 dots are provided here. So you can count now 1, 2, 3, and the 2 dots 4. 4 2s are 8. So aluminium is completed with 8. Then dot and across 2, dot and across 4 now, dot and across 6 now, and the 2 dots, they are 8 now. So aluminium is completed with 8. It doesn't make any difference to chlorine at all. Right? Any question? Okay, dot and across of BH3, BF3 and NH3. This structure we need to work on it, and let us see NH3 and BF3. So this is nitrogen with 2 dots on it. This is ammonia actually. Okay, now we'll show the dative covalent bond with another color. Let me choose the color. Okay, so the dative covalent bond, and then the other one, which is boron. Boron is having 1, 2 and 3 F connected, and see, dot and across, 6 pairs or 6 electrons are already there, 3 pairs, but it can still accommodate 2 more electrons. So the arrow is going from here to here. This is the dot cross for NH3, BF3 molecules. When they are making, this is the dative covalent bond between them. Can we move on? So individually and overall you can draw. I've already drawn the structure. Okay, let's see, can we draw AlCl4? Draw a diagram display formula for AlCl4 negative and identify the dative covalent bond. Okay, AlCl4, we will work on this now. AlCl4, there's a big space here, so let us work with minus charge on it. This is the last part at the moment. First of all, I'll go for aluminium. Aluminium with 1, 2, 3, dot and across 1, dot and across 2, dot and across 3. This is chloride, and this is another chloride. And then we will draw Cl. Cl is going to offer a pair of electrons here. Okay. Are you with me, everyone?
Yes.
Okay. See, there is a negative sign also. So let me indicate that negative sign also. From where is the negative sign coming? We will work on this now. The negative sign is coming because for now I'm drawing for this chlorine. 1, 2, 6, 7 electrons are there in chlorine. Chlorine has accepted 1 electron from somewhere else. See this dot cross, and the rest of the chlorines, if I draw for the rest of the chlorines, you will see that the rest of the chlorines are quite fine with the number of electrons. They're all having red electrons, dot dot. Let me draw, dot dot, dot dot, dot dot. Okay, then okay, okay, and okay, 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 and okay. Now see, this is because of the negative charge. -1 is because of that particular electron. So you need to be very careful about this. -1 charge is there, and this is because of this electronic pair. Right? The structure is tetrahedral. And the bond angle is 109.5 degrees. Which bond angle? This bond angle, 109.5 degrees. Is this clear, everyone?
Yes, sir.
Okay, so we are on page 81. Inshallah, we'll continue with this one tomorrow. At the time, I think it's the break time, so we'll have a break. This is your second class, right?
Yes, sir. Second chemistry.
Okay, so we'll have the break now.